In this lesson, we're going to look like how can I represent ratios. So where you want to start there is thinking, what is a ratio? Well, it's a comparison of two quantities using division. And there's several different ways to do this. We're going to start with this first statement here. We're talking about a flower shop, and so in a flower shop you might hear some of these things being said on a given day. This first statement here is the one I'm going to start with. In the daisy smile bouquet, so this is just a type of bouquet, there are 2 white daisies for every 3 orange daisies. And so when we start thinking about that statement, we want to come up with a relationship that shows between the 2 different types of daisies. So my first thought is, let me just draw a picture to show that. And so in this model that I drew these 2 to represent 2 white daisies, and I drew these 3 to represent 3 orange daisies. So for every 2 white, there are 3 orange. Now, when I'm comparing these different quantities, there's different ways I can compare them. I can say white to orange, and then you can reverse that. You can say orange to white. In this case, white to orange could be represented as 2 to 3. And then orange to white would be 3 to 2. And these colons here is a kind of a standard notation as one possible way to represent a ratio that I'll get into more in a few minutes. And the other ways you could represent this could be white to the total. And this would be more like your traditional fraction. So this would be 2 to the whole total is 5. And then at the same time, you could do orange to total. And go ahead, and you might have guessed by now that the orange to total is 3 to 5. And all these ratios can all be written using a colon. Now within these 4 different comparisons that we have, these first 2 are the type of comparisons that you would call part to part. These are part to part ratios. In these part to part ratios, you are comparing one part to the other part. These bottom 2 options are what you would call part to whole ratios, because you're comparing a part to the whole. So we're looking at 2 types of ratios here. We have part to whole ratios and part to part ratios. Both are important to know because depending on your situation, you may be given the information in a part to part ratio or part to whole ratio and need to interpret that to solve a different problem. Now, in terms of notating these ratios, there's 3 ways that you're going to want to know how to notate them. Those 3 ways would be kind of words, a colon, and in fractional form. Oops, let's get more space. Let's start out discussing how you would do that in words. So in words, you really just kind of say what I've been speaking. So it would be 2, for the first one, the 2 to 3, the part to part. There would be 2 white daisies. So I'll just say 2 white to every 3 orange. And again, in the part to part, you just reverse that. 3 orange to every 2 white. So this would be how you'd represent these part to part ratios in words. Staying on the part to part, how would I represent them with a colon is you would say 2 white, colon, 3 orange. So very similar to what I did before, except I'm just including the units here so I remember what I'm talking about. And then you would reverse it, 3 orange to 2 white. Where I most commonly see part-to-part ratios is when I'm like, sometimes I'll buy like a concentrated cleaning solution and it'll say, oh, mix 1 part solution to 10 parts water. And so then I have to say, okay, well, that's a part-to-part ratio, 1 part of the concentrated solution to 10 parts water. And that's kind of what I'm dealing, that's exactly what I'm dealing here, 2 parts white to 3 parts orange. And then with a fraction, it would be just 3 white, oops, sorry, I made a mistake there, 2 white over 3 orange. So it looks very similar. It's basically the fraction is 2/3. And then you would reverse it, 3 orange to 2 white. It's very important that when you're talking about a part-to-part ratio, you definitely want to make sure that you are very carefully, and even in a part to whole, you want to very carefully track your units, because this looks like an improper fraction on the bottom, but it really isn't, because it's part to part. When we get to part to whole, that's where you're more relevantly looking at like a fraction. So now when I'm looking at words with the part to whole ratios, you're looking at 2 white to 5 total daisies, and then you're looking at 3 orange to 5 total daisies. The colon would be 2 white, colon, 5 total, and then it would be 3 orange, 3 orange, colon, 5 total. Finally, in the fractional way to represent this, you would have 2 white to 5 total over 5 total and 3 orange to 5 total. In this case, if you took all of the parts in a part to whole ratio, you should be able to add up to equal your whole. So like 2 plus 3 equals 5. So that would be the whole bouquet or arrangement of flowers. The next thing I want to talk about is what a rate is. So these two statements, 5 daisies cost $7.50. And there are 10 daisies in a small vase. These are rates because they're comparing 2 different quantities, but specifically 2 different quantities that have different units. In this case, you're comparing daisies to money or daisies to a vase. So we can go ahead and write some rates for these, which are down here. A rate is a ratio that compares 2 different quantities measured in different units. So the first statement that said 5 daisies for $7.50 could be written also, I would say that already was written in word form. You could say 5 daisies colon $7.50. Or you could write it in fractional form, 5 daisies over $7.50. And then the second statement said 10 daisies in 1 small vase. So I could even indicate the word small here. Small. So you write your rate of 10 daisies colon 1 small vase, or in fractional form, 10 daisies over 1 small vase. And what this is this is a special type of rate called a unit rate. A unit rate is when you compare 2 measurements in which the denominator has a value of 1 unit. So this is just daisies per small vase. So this is a value of 1 unit, and that unit rate is very helpful if you're like determining, okay, well then if I have 2 small vases, how many daisies am I putting in? Okay, well then you say 10 per small vase, so 10, 20, 2. Okay, so 20, and there'd be 20 daisies in it. So I want to come back to solving a couple problems. So say we go back to that ratio where we're talking about the daisy smile bouquet, and we're saying 2 out of 5 daisies are white. So I'm sitting there saying 2 white over 5 total. All right, what if there were 8 white daisies? So how many total daisies would there have to be then? Or there would be 8 white daisies? Well, I was sitting here and saying, okay, if I have 2 white and I want to get to 8, how do I get to 8 white? Well, that's kind of like things as equivalent fraction. So I do 2 times 4, that's going to equal 8. Well, in order for this to be an equivalent ratio, you basically need to multiply by 4 over 4 because this equals 1. So 5 times 4 is 20. So the total number of daisies, if I have 8 white, then I'm going to have 20 total. And then at the same time, you can kind of work the other way. if, say, I have the 2 white over 5 total, and I know that I want 25 total daisies, well then how many white daisies do I need? Well, okay, how do I get from 5 to 25? That's times 5. So I need to multiply by 5 over 5. So 2 times 5 is 10. So in that case, I have 10 white daisies and 25 total. And so you're going to need to work flexibly within solving problems. If you can come up with the ratio, you can use that to solve a variety of problems. Say you're working in a flower shop and people have different size orders, you can do things like that. So again, I'll go ahead and finish up this one. It says, how can I represent ratios? This is a quick overview of how to represent ratios, how to use them, and then you'll be able to apply this to solve a variety of problems.